All right, guys, time to do some algebra. So in order to get this started, I'm going to actually copy down this part right here. So if you haven't seen the first videos, I do recommend going back to those. But what we're going to do here is copy everything down the way it's written in this activity. So we got this 3, and then we're going to do the exponent power. This just makes it easier for us to see everything that I'm doing, so that's why I'm copying everything down. So the first thing I want to do is since I want to solve for x, I need to get rid of this -2 first. So I'm doing backwards order of operations. So the first thing I'm going to do is copy this entire thing down. This is the easiest way to kind of solve this. Copy it down, paste it here, and I'm going to add 2 to both sides. So I'm going to get rid of this -2 because I added 2, and this becomes a 40 because 38 plus 2 is 40. Then the next thing I see here is like, well, here's a multiplication of 5. So I'm going to divide both sides by 5. So I'm going to copy this row down, and copy this down, paste it here. I'm going to divide it by 5. So this times 5 goes away because I'm dividing by 5. And this becomes an 8. So the next thing I want to do here is I want to do log base 3. So in other words, what I'm going to do here is if I do log base 3, because this is our base. So in order to get rid of a base and just get the exponent, you have to do log base. So doing a log base by the base just kind of eliminates that base. So by doing a log base 3, this goes away. I'm just left with the exponent. On the other side, I have log. If you need a subscript, it's right under the superscript. So we go here. I'm going to say log base 3 of 8. Another way of writing this down would be, and from now on, this will be the last time I use the sub base. I'll just write it as kind of the base 10 from now on. So I'll only use base 10 because that's what we're going to be plugging into our calculator. So I'm going to have log of my argument, log base 10 of my argument. So log base 10 of my argument over log base 10 of my base. And then what we want to do here is I'm going to copy all of this down because I don't want to rewrite it. I'm going to copy all of that down, go to the next line, paste that in, and enter. I want to get rid of this +3, so I'm going to subtract 3 from both sides. So that +3 goes away. And in order to get rid of that +3, I had to subtract 3 from both sides. So this is what I'm going to enter into my calculator. And this is going to be approximately equal to, and I say approximately equal to because they're telling us only do 3 decimal places. So I'm going to say this is approximately equal to, I'm going to use this squiggly little equal sign. Go to my Desmos, and I'm going to do log of 8 divided by log of 3. I'm going to subtract. Let me get rid of this. I was helping out with geometry earlier. I'm going to subtract the 3. So I'm going to subtract 3. And I get this -1.107. This 2 is not a 5 or greater. So it's -1.10, -1.107 should be our answer. Let's see how close we are to Desmos's answer. Right on the spot. And you can see they did the exact same steps I did. You're just doing algebra. All right. So they actually wrote down the names of the steps. I was not going to do that. That's too much work. So let's take a look at what we have to do here. All right. So we have this function here. And this function tells us how much these cells are going to keep duplicating. So where the number of cells, blah, blah, blah. after how many hours do we get this many cells? So in other words, the question they are asking us is, if we have 10,000, how long did it take us to get these 10,000 cells if they double every hour, basically? So in order to do this, the first thing we're going to do, we're going to log both sides by 2, log base 2, and that's going to give us t plus 1. So whatever our log of 10,000 divided by log base 10 of 2 is, subtract 1, that will be our t. So I apologize. I only meant that I was going to use the base log bases when I'm showing my work here, but since I was handwriting it, I was like, well, might as well just handwrite it correctly. So I'm going to go here and I'm going to go back to my mouse first of all. We go 10,000 log base 2, and I'm going to subtract the 1. I end up getting, how many decimal places does this want? There, how many hours? Round your answer 2 decimal places. Okay. So 2 decimal places, 28, that's 7 is greater than 5. It is 5 or greater. So we're going to do 12.29. So I'm going to say 12.29 and submit that. Cool. So we got that right. Make sure you're always reading it. So if you have an answer with a decimal, odds are Edmentum told you how many decimal places it wanted you to do it. All right. So let's see here. So we have this other problem. So in order to show our work, I'm going to divide it by base 7. So I get x minus 2 equals log 30 over log 7. And then I'm going to add 2 to both sides. So x equals log 30 over log 7 plus 2. All right. So what I get here is, I'm going to change this 10,000, 30, and change this to 7. And what was it, plus 2? Yeah, plus 2. Log 30 over log 7 plus 2. Really simple to do. How many decimal places did Edmentum want? 3 decimal places. So if I look here, 1, 2, 3, that 8, this 8 right here is 5 or greater. So it's going to be 3.748. I'm going to round that 7, this 7 right here, to an 8. So 3.748 should be my answer. Got it. All right, so let's clear off the board. Again, if I ever go too fast, guys, feel free to rewind. I'm sorry. All right, so let's take a look at this one. This one already has log base 7. Okay, so what we're going to do here, solving a log, I personally think is a lot more easier than solving an exponential, because you need logs to solve exponential equations. If you have a log function, it's so much easier to solve, because what we're going to do is we're going to base both sides by 7. This is going to give us 5 plus 11x equals whatever 7 squared is. Luckily, we know 11 squared is 49. 7 times 7 is 49. So I'm just going to jump straight to that. Unlike logs, usually you can do an exponential a lot easier. So it requires less steps. This 5 plus 11x can be viewed as 11x plus 5. So in other words, we're adding 5. So we want to subtract that 5, or what I like to say is, this is a positive 5. How do we get rid of positive 5? We're going to subtract it. We're going to make it negative. So we get 11x is equal to 44, because 49 take away 5 is 44. Therefore, x is equal to 4. You might notice that it's a drop-down menu, and also there's no rounding. So we should get 4 as our answer. Perfect. All right. Moving on here. They're asking us to solve this. Now, if we notice, both of these have the exact same base. So that means I can rewrite this as, luckily we have this already here. So I'm going to grab the equation editor and I'm going to rewrite this as log. This doesn't count as my, like, I'm just going to write it correctly from now on because they have it this way. Log base 2 of, now we're going to use theirs parentheses because I want a fraction, so I wanted it to get bigger. If you use your own parentheses, the parentheses don't get bigger. So you want to use their function to so that it does get bigger. And we're going to have 3x plus 1 over x. Now, a lot of students think, oh, you can simplify this to 2x. You cannot. There is a plus sign. You cannot divide by x until you finish this addition operation, which you can't do because x is a variable. So we can't do that. So just keep that in mind. Then we're going to do this by 2. Now, what we're going to do is we're going to base both sides by 2 to get rid of this. Or I can just pretend that that log doesn't exist over x, and this is equal to 2 to the power of 2. And it's important to remember that this is our power. This is our base. So let me clarify that a little bit more. So the thing in green is the base. A lot of people think that the blue would have been the base, but it's not. It's actually our power right here. So I don't like that they did 2 2s. It just makes it a little confusing for that part. So what we then do is we're gonna, so 2 squared is just 4. So I'm just gonna copy this down. Copy. Paste. I'm gonna change this to a 4. And then I need a, oops, change the whole thing to a 4. And then I'm gonna multiply x by both sides. So same thing here. I'm gonna do 3x plus 1 equals 4. So then I subtract both 3x from both sides, and I end up getting 1 equals x. Or in other words, x equals 1. But subtracting that 3x makes it super easy. I was debating if this was going to take a while, but it's actually not that bad because you subtract the 3x and you're just left with 1x. So pretty simple. There we go. Here you can see how they worked it out. I don't know why they didn't write the step subtract 3x from both sides. Should have. They don't even have a word here for it. I always call it basing it by 2. You put the base of 2 there. Here they just didn't write down subtract 3x. Oh, they didn't even write down using the quotient rule here, or quotient property. All right, guys. So in this one, definitely make sure you're writing down what you're struggling with. Do you know when to use which property or which other ones? You saw me in the earlier video realizing that I should have used the quotient property earlier, and that would have made things so much more easier. But just as long as staying true to the properties, you should be fine. Definitely reflect, write a brief evaluation about yourself and how you're doing. All right, so let's talk about natural logs. So remember when I talked about E? E is this natural number. It's approximately 2.71. That occurs in nature. It's just how things, if you're calculating continuous growth, meaning how something grows exponentially, continuously, meaning that it grows every second of every day, just keeps growing exponentially. We usually use E because it just happens so perfectly. And then we're going to use logarithmic functions. So how do we get rid of log? Well, if we get rid of an e, we want to use log e. Well, it's kind of weird to use log base of a number. So instead of using this thing log base e, we use a thing called ln, the natural log. So log base e is natural log. And a lot of times, some people even use natural log to simplify certain logs. So let's say I had log 3 and 9. So we know that 3 squared equals 9. So log 3 of 9. Well, we've learned that we can write it as log 9 divided by log 3. As this is known as the changing the base property. You can also use ln if you wanted to. You can do this is the same thing as saying ln 9 over ln 3. Because changing the base, you can do any base to use this division property. It's really cool. I was expecting Edmentum to go into more detail on why, but they didn't. So they didn't. I won't because I don't feel it's necessary for the learning process of understanding why, just as long as you understand that you can do it. See, you get the same thing. All right, so moving on. So ln is a way to cancel out e. So if you're dealing with exponential growth, you're gonna have to excuse me, you're gonna have to ln both sides. So that's just how you get rid of e is it's natural log. Natural log is how you cancel out e as your base. So here's more practices on how to do that. I kind of just want to get into one myself, but you can check this out if you really want to take a look at how to cancel out log. You see here they're doing everything the same, dividing. Uh, and this is actually an example of what I just did, where I'm like, let's just do ln of something over something else. So ln of your argument over ln of your base, you can use that instead of using log base 10. But here's where they cancel out the e's. This is one where we can do it by changing the base using ln instead of log base 10. All right, so we can do that here. This one, we're going to use ln to cancel out the e. So we're going to divide by 2000. Then we're going to ln both sides to get rid of the e. The e and the ln cancel out. And then we're going to have to divide by 0.05. We can plug this into Desmos or your own scientific calculator and get the answer. All right, so let's solve some logs. All right. Oh, great. You guys saw that the answer was there, but let's get it done anyway. So what we're going to do here is we're going to subtract 9. So we get 3e to the x equals 4. That's because 12 divided by... I did a boo-boo. I don't know why I divided by 3. I was supposed to subtract the 9. So we're going to subtract the 9. We get 3. We're going to divide by 3. We get 3x equals 1. So from here, we're going to ln both sides. So I get x equals ln of 1. Now, if you've ever seen a log function or an exponential function, an exponential at 0 is 1. So an exponential at 0 is always 1 unless there's like something else causing it. So if you flip it, logs are the inverse of exponentials. So that means the x's and the y flip in an exponential. So log of 1, when your x is 1 in a log, your y value is 0. So that's why before I erase the answer, this ended up being 0. So ln of 1, log base 10 of 1, it's always going to be 0 because anything to the 0 power, including x, or including e, is going to be 0. So e to the 0 power is 1. Don't forget what logs are. It'll help you out when solving those. So this is asking e to what power gives us 1? E to the 0 power gives us 1. It's just a little weird to see it because we don't see it as log base E of 1 is x. So just keep that in mind. ln is log base E. Let me clear this out. All right, so moving on to here. So now we have this function, and it's telling us we have 0.2 milligrams. So first thing we're going to do is we're going to put 0.2 equals 10e to the negative 0.3 t. We're going to divide by 10. Dividing by 10 just means moving the decimal place to the left one spot. So I'm going to do that right there. Get e to the negative 0.3 t. To get rid of e, we're going to ln both sides. So ln of 0.02 is equal to negative 0.3 t. Then t must equal ln of 0.02 divided by negative 0.3. All right, so let's go here. So we're going to do ln of, what was it? ln of 0.02. And we're going to divide that by negative 0.3, was it? Negative 0.3. And we get 13.04. Is it 2 decimal places? Nearest integer. All right, so nearest whole number. So we want 13. It takes about 13 hours for the human body when amount of drug is administered. Number of milligrams of a drug in a person. So how long it takes for a drug to how much of a drug is still left in the human body. So let's go in here. Okay. And then you can see the steps here if you want to take another look at how they did it, as they have it typed out nicely. So now let's solve for this answer here using natural log. So in order to solve this using natural log, what I'm going to do here is I'm going to divide by 20. So I get 3x equals 5 over 20 is the same thing as 1 over 4. So I get 0.25. The way I remember is this is 1/4 or 1/4. So a quarter is 0.25. And then in order to get rid of this 3, I'm going to say x equals ln of 0.25 or 0.25, however you want to do, over ln of 3. So in order to get rid of this as a base, normally we do log base 3 of both sides, but since we want to do it nice in our calculator, we're going to use natural log instead of log base 10. Either way, you'll get the same answer, whether you use log or whether you use ln, but they want us to use ln. So we're going to do log, or ln, sorry, ln of 0.25 divided by ln of 3. And that's going to give us, let's see how many decimal places they want, 3 decimal places. So that would normally be a 1, but this 8 rounds it up. So we get negative 2 or negative 1.262. So negative 1.262. Enter on that and we get it right on the dot, right on the money. Just to show you guys that it's the same thing. I know I've shown you guys already, but I'm going to change this to a log. Change this to a log. And we get the same answer. What do you know? I'm going to change it back to ln because I have a feeling they want us to keep using ln to solve it. So we'll leave it like that. All right. So one thing that's important to note is that doesn't mean they're interchangeable. Let's say I had ln on the top and a log on the bottom. Completely different answer. You can change the base, but make sure you change it to the same base. All right, so looking at this one, in order to fix this, to solve for this, we're going to use log property of quotient, the quotient property, so that's going to let us divide that out. So we end up getting ln of x minus 2 over x minus 3. This is going to give, and this is equal to 1. So then we're going to do e to both sides. We're going to x minus 2 over x minus 3 equals e to the 1. So this becomes x minus 3. We're going to multiply x minus 3 to both sides. So it's x minus 2 equals e to the 1. I'm just going to call it e. It's just a number. It's kind of, I don't like calling it just e, but it is technically just e. E x minus 3e. We want to get all the e's together, or all the x's together, I'm sorry. So if we want to get all the x's together, we get this, and all the regular numbers together, we get 3e minus 2. So I'm adding 3e to both sides. I'm also going to subtract x from both sides. So I get this e to the x minus x. And to make this a little, quote unquote, easier on me, what I'm going to do is I'm going to factor out this x. So I get e minus 1. And this is still the same thing. So I'm going to get, this ends up being x equals 3e minus 2 over e minus 1. I don't know how Edmentum's going to do this because I feel like, whoa, this is a lot of stuff to do, Edmentum. What are you doing? But we'll see how it goes. I kind of glossed over this part, so if I lost you, please feel free to rewind. But I also forgot to kind of write this part where it's e minus 2 equals e to the 1 x minus 3. That's probably going to help you understand it a little bit more because then you have to distribute. All right. So moving on. Moving on. I haven't even solved this yet. I'm going to clear that out. I have a big fraction here, so might as well hit the fraction button now. 3e minus 2. 3e minus 2 over e minus 1. E minus 1. So I get, how many decimal places does it want? 3 decimal places. I get 3.58. Oh, not 81, because this 7 turns this 9 into a 10, meaning actually, doesn't even have to be that complicated. This 9 turns that 1 into 2, so it's 3.582. So my answer is 3.582. And you can see it right, 585. What happened here? All right, let's take a look here. E to the 1. Oh, I see. Theirs is a little less accurate because they approximated the value of e. This is honestly probably easier. I should have evaluated e to the 1. The reason why I didn't is e to the 1 is a number that goes on forever. Even this calculator cuts it off a little early. E's just this very weird number that keeps going on forever. Kind of like pi. Pi goes on forever as well. So theirs might have been a little easier. So even I, when I would do this evaluation, would criticize myself for not evaluating E. Also, even I would debate on if that's a good idea or not. But if you're having trouble with these, again, feel free to leave a comment. Let me know how I'm doing, what I can do to make this a little more easier for you guys. All right. Definitely write down. I recommend evaluating yourself. Um, that way you can think on what you didn't understand, so it's easy for you to make a comment. So I would definitely do self eval before. Self evaluation is something you should always do before you ask for help. That way you know exactly what you don't understand, like what's trumping you when you get to what part, what doesn't make sense. It makes it easier to ask someone else for help if you've already thought of this. All right, so moving on, I believe we're very close to the end now. So summary, so this is the end. So make sure, again, always watch these videos, guys. They're always very helpful. um, and it also sums up how you should be thinking about this for the test. If you kind of get in the mind of the people that created this, it'll help you for the test. All right. So good luck, guys. As always, what I always recommend is do your practice. You know, do your practice. If you get it wrong, uh, before you take the test, what the beauty of this is, it explains it to you. So I'm going to pretend to get it wrong because it showed me the answer there. It'll explain this to you. If this doesn't make sense, go back, check your guided notes out, and see why this doesn't make sense. All right. All right, guys. Well, I'll see you in the next module. I know this one was kind of weird because I did 3 videos, but I did them right away. I'm gonna try to have one video out during the weekday, or one module done. So in this case, it's Algebra 2. Going to be doing pre-calculus tomorrow, and then I'll round back up to Algebra 1 and geometry. So I'm going to try to keep this in order. Um, Last week was very busy. That's why I didn't have this video out till today. But that way you guys kind of have an idea of what's going on. It's always going to be in that order: Algebra 1, geometry, um, Algebra 2, and then pre-calculus, and then back around. So if you're subscribed to the channel, you'll see that there's videos that don't have to do with your subject. That's the circle I'm going in, and I'll explain this in the other videos to the other subjects as well. All right, guys, see y'all later.